right. So hopefully now you guys
Hopefully, I can be heard. Um, if it's picking up my volume or what? Oh, I think it is. Okay, perfect. So, if anybody wants to come in and discuss the topic at hand, come on in. Or let me pull up the link. Hold on, give me a minute. Well, I'm not going to put the link public because we still have people sniping and stuff. But if you want to get in, just ask to join, and I will invite you to the hangout. I think there's some people watching, but I was watching Antonio's hangout for a while. Then I got busy and sidetracked by other things in life. And yeah, I actually did, Spence. Yep, I did. I did terrible. Absolutely terrible. We learned nothing. Um, but if you failed the exam, you still passed the class if you did the final project. So you should be good. Spence, you can come in if you want. Um, I'm about to invite you. And I usually don't even like talking about like flat Earth creationism and all that stuff, but like it was a topic, a discussion in Antonio's room, and I found it like fairly strange how these Christians who are supposed to be like advocates of science, the same Christians who deny evolutionary theory, and deny Big Bang cosmology, all of a sudden, you know, well, not all of a sudden, but um, they couldn't explain or they couldn't even like debunk any of the flat earthers' claims about why he believes the Earth is flat, which were fairly easy like points to debunk. Um, why does the sun look so far away or something like that? He was bringing up. Um, what else did he say? He said he tried to make some excuse that the reason why you don't see the entire Earth when you stand up on a mountaintop isn't because the Earth is round, but because of the atmosphere, which is completely bogus. Um, has like has nothing to do with frame of reference. So yeah, if you want to come on in, I'm gonna start inviting some people. All right, I was waiting for some people who wanted to join, but yeah, my point on the whole like flat Earth creationism thing is yes, the Bible does teach that the Earth is flat. The people who wrote it, they obviously believed in that type of cosmology. And as I always say, I don't have a problem with that. I don't think the Bible is a science book. Um, and I don't think you need to fight for or I don't think you need to make people make a choice if they're religious, right? Like if they're a Christian, I don't think you need to make a choice between the Bible and science because the Bible is not a science book. It's a religious text. And like when people start to understand this, then we'll start to move on with our lives and stuff. So a Christian anarchist came in for a minute, then he left out. Don't know what happened. But I actually do have something to show you guys too for the people who are like listening and stuff. All right, so this is my driver. So this drive right here actually comes from General's like folder. So General actually like just blessed me with some textbooks, and every now and then I open up like an astrophysics book and I study it. And so you could say like I basically got like a college education for free thanks to General. Um, but this book is actually Fixed Journey to the Cosmic Frontier. And so right here it's explaining not necessarily hold on longitude and latitude, and basically it goes on, and I like how when it first starts off it talks about coordinates and what a coordinate system is, and we have something called, and I actually want to look for it in the book. There you go. We have something called terrestrial coordinates. So the terrestrial coordinate system is used to locate places on the Earth. The coordinates the system uses are latitude, which describes distances north or south of the equator, and longitude, which describes distances east or west from the 0 point. And then it says the 0 point is located on the equator directly south of Greenwich, or that's England. And if you go up, it'll give you more information on how terrestrial coordinates and etc. are used. I want to look for, give me a second, guys. This is a very good like explanation of what it is. So basically it goes and it says, hold on, let me zoom in so you guys can actually see the words. So the book says, if I asked you where we are, one way you can answer would be by giving me a detailed verbal description like the one illustrated in figure 1.6. You could say that we are standing on the grounds of the Riverside Observatory. The observatory is located about 13 kilometers south of Iowa City, where the University of Iowa is located. Iowa City itself in eastern Iowa, about 80 kilometers from the Mississippi River. The state of Iowa is in the central United States and almost in the central of the North American continent. North America stretches from just above the equator to nearly the North Pole of the Earth. Obviously, unless you were talking to a creature from another planet, you wouldn't really have to describe your location so elaborately. However, the usefulness of a verbal description of your location depends on how familiar your listener is with your surroundings. If you try to tell a stranger how to find your home, a verbal description may be almost useless. You might be more successful if you give the stranger the street address of your home. When we use street addresses, we are using a form of coordinate system. Coordinates are a set of numbers that can be used to locate something. Thus, 1715 7th Avenue, which is not my address, combines a pair of numbers that locate a particular house. Another set of coordinates could be used to locate a particular seat in a classroom by giving room, or I'm sorry, by giving the row, and let me go, I got to go down. Don't know what happened. By giving the row, and it just says longitude right here. I think a page is missing. Uh, yep, I think a page might be missing. It's talking about longitude and latitude. And it's basically just talking about like the 0 point, which is this is really important. So you guys should already know what longitude and latitude are. If you don't, just Google it real quick. But this is the equator. Um, so that would be like the 0 point, and then longitude is going the long way. Is going that way. If you can see my cursor, and latitude is going up north and south. So longitude deals with east and west, and latitude deals with north and south. Hence why we call it um, the Near East and the Western Hemisphere. So if you are on the Western Hemisphere of the planet, you are like in Europe or North America, South America, etc. But towards the Western Hemisphere of the planet is like the Near East, and the eastern part of the planet. I said the West. Towards the Eastern Hemisphere of the planet, that's where you get the Middle East and etc. Like Asia. So that's why we call it those things. So we live in the West, and the people over there in the Middle East live in the East of the planet. So it says for a coordinate system to be useful, everyone must agree about its 0 point, where you start counting, and in which direction you count. So all astronomers everywhere on the planet, they all have to agree on where the 0 point is, which is the equator. So like right here, this quick little snippet, it says coordinates are a set of numbers we can use to locate something, which is what we just went over. And so, let me see. Oh, let me zoom in so you guys can see the words. So when we make up a coordinate system for locating places on Earth, we also must agree on the 0 point and the direction in which we measure, which we just went over. And the most commonly used terrestrial coordinate system, the 0 point is a point on the Earth's equator. The Earth rotates about its axis, and oh, it rotates on its axis or about its axis, and it's an imaginary rod that passes through its surface at the north and south pole. So then I'm going up. So the imaginary line that circles the Earth midway between the poles is the equator. The equator is an example of a great circle, which is a circle that divides a sphere into two equal parts. The equator divides the Earth into northern and southern hemispheres. The location of each place on the Earth can be specified uniquely using latitude and longitude, both of which are defined using the Earth's equator. Latitude is the angle between the equator and the geographical location. Longitude, which is the long way, that's basically like I just said, that's east and west, around the equator to the point nearest the location. So the 0 point for the coordinate system could have been chosen anywhere on the equator. For historical reasons, the 0 point, so this is the point that every astronomer on the planet agrees on. For historical reasons, the 0 point is on the equator due south of the former location of the Royal Observatory in Greenwich, England. So this is the 0 point. And we use terrestrial coordinates for like when we're launching satellites and trying to map out where certain places are on the planet. And so I went through this whole song and dance basically to say if you do want to think that the earth is flat and etc., um, how do we implement like a coordinate system? Like where do we locate things on the planet? Like how do you put that into your model? Because we can like put forth the terrestrial coordinate system and it explains things that we see, and like terrestrial coordinates are the reason why we're even able to like launch satellites and stuff out in space, because we can map out right from which place we lost the satellite or where a specific satellite is at from the terrestrial coordinate system. And then we have something called celestial coordinates, which I don't really want to get into right now, but that's just that those are just one of the, well, it's not even evidence, but it's something that we use in like everyday scientific practical application when it comes to astronomy. We all agree and we all use. And if the Earth is flat, um, yeah, we like a lot of things just don't make sense. Um, Somebody said Antonio's hangout just ended, so nutters are available. Yeah, people are pretty strange. So yeah, that's if you guys if you guys want to, I think that like I said, the name of that textbook is called Fix's Journey Through Astronomy. Hold on, let me look at it again. It is the name of that textbook is, I'm zooming out. Fix's Journey to the Cosmic Frontier, and this is the fifth edition. So you guys can go, you can look that book up if you want it. I just find it useful because like in my spare time, I just like getting into like astronomy and astrophysics and stuff like that. That's like my favorite field of science. Like for people to go around just bashing modern day astronomy and thinking that the planet is flat and like everything is like in like a dome and stuff, um, hurts my heart. Shar, I'm about to invite you to the hangout. I don't know if you want to come in or not, but hey, I'm just gonna invite you. Uh, I'm inviting more people now. Who else said they want to come in? All right, I'm gonna check my messages. Oh, hey Brenda, I haven't seen you in like a while. It's been a minute. Do you want to come in? Hold on. Where you been at, Brenda? All right, I'm about to check my messages. If you sent me a message saying you want to come in, I just sent out some invites to some people. All right, I'm checking my messages right now. Yeah, it's really weird how like people are like reverting back to like these like old cosmologies just because they're trying to like uphold their religious beliefs and stuff like that. Like you can be religious and you can hold to the science and stuff, but I don't know. I don't see why you would like that because you honestly do have to like be lying to yourself. You sure? Oh, you sent me a message earlier. Okay. All right. Sending out links. Start checking messages. Sending somebody else. No. You just look me up on Google Hangouts and I should pop up and send me a message. All right. I'm looking for your message, Brenda. I don't see it. I'm just going, you know what? Hold on, give me a minute. Yeah, I thought I typed your name in right. Hold on. I'm going to see if I can just send you an invite from here. Uh, Trying to get some people in here so I don't have like an echo chamber, literally, because it'll just be me in here talking about my point of view and nobody else will be in here. Oh, here you go. Wait, your name, it pops up. Here you go. It popped up for a second. Didn't I just sent you an invite. Flare Earth Bimbo, do you want to come in? Hey, Brenda.
There we go.
Where have you been? I haven't seen you in ages. You been all right?
Well. Um, well, the socially correct thing to say is I've been just fine.
I'm glad to hear that.
The fact is that I've had quite a number of doctor's appointments recently, and um, I'm feeling good today.
Well, that's good to hear. I'm happy about that. I'm trying to invite some people in here.
So,
Uh,
so Antonio had his hangout. He had a number of people.
yeah, do you see it?
Just the last couple minutes of it.
It was wild. I still can't believe people are like arguing about this in 2017.
Well, for something like this, I prefer to keep it really simple. So, I mean, if you get really complicated in the math or the science, then they just get, the eyes glaze over. They don't understand or whatever. But if you just keep it really simple
Right.
to something you can understand, then it gets really difficult for them to deny it. It's pretty, there's some things, there's a lot of things actually in science that are not absolutely certain. The fact that the Earth is round isn't one of them. I don't know if you even call it science, since we can pretty much just observe it. I mean,
Right.
if I hold up a cup in my hand, that's not science. I'm just observing a cup. And we put people out far enough that they can just turn around and look and see that the Earth is a large sphere floating in space. We can see that. It's more difficult to prove that the Earth goes around the sun. That's not immediately obvious, but the fact that the Earth is a ball pretty much is, if once you get far enough away.
I don't know what their problem is with the Earth being. Well, no, I do because they say the Bible says that the Earth is flat or whatever. Which, whatever. That's
Not all of
I
them.
don't think that's what you say.
I don't think all of them are not. I don't think that for all of them it's a religious issue. I think maybe for some it is. For a lot of them, it's that they feel like they've been really shut out um, economically and politically. In They feel that there are these elites in charge of the political system, and not just the United States, but in the UK too. There's people that feel the same way, and I'm sure in other countries they feel that they've been shut out of the decision making in politics, and and they're suffering because economically they're doing poorly as a group, and so it becomes easy to find somebody to blame for that and find a reason. And this is one, and in honesty, you know, you just walking around as a ordinary person, yeah, the earth looks flat. It doesn't feel like it's moving. Doesn't seem like it should. So if you have all these people that you despise or that have been putting you down economically all your life, and they're telling you these things, it's easy for people to say, "Well, I don't need to believe in those what they say," you know, because these are people who have their, you know, are in charge, and I don't get a say in things. So, you know, it makes them feel like makes them feel better.
Hmm. Yeah, it's sad because they don't understand actually how these things work. Because yes, like sure, like scientists come to a consensus based on what other scientists say and based off the evidence and stuff like that. And so I guess they feel, well, I'm not a scientist, the scientific community doesn't care about what I say, which honestly they don't. But what the scientific community does care about is the truth.
And a lot of these people have been failed by the educational system in whatever country they're from. They've not had a good education necessarily. Or maybe I'm wrong. Maybe they've had a good education and they just rejected it for some reason. Maybe that's not true. I guess I don't know. It seems like these are people who are. The one person I've been watching recently goes by the name of Dell, and he's from a website called Beyond the Imaginary Curve. And he seems like a very lower class working white male from the UK in somewhere. I can't place the accent. I don't know him that well, but
Hearing a lot of
you know,
assumptions. A lot of assumptions.
um, what what assumptions?
Everybody's broke off their ass. I don't believe we're on a globe. I make way better than average money.
Oh,
Don't
okay. Well, as a group, I think some of these people are economically, socially, politically disadvantaged.
Well, they might be. I don't know. I'm not.
Yeah.
I'm not a flat earther either. I don't believe in the globe though. I don't think we're on a globe one bit.
You're not a flat earther?
No, I believe we're in the inverse of a geocentric model.
Oh, okay. Why is that?
Um, Mainly because, well, here I'll give you my three major ones. The magnetics that we show the Earth having have to be done as the Earth as a dynamo, because if you heat a magnet, it loses its ability to be a magnet, and we have no way of showing that there's any mechanism of the Earth actually being a dynamo. That's just an assumption, especially in the globe model. We got the Planck satellite data and WMAP data that shows what we call the axis of evil of what our universe looks like, and it's pretty much pointing at Earth, which shouldn't be happening in the Copernicus theory.
I have no
And
idea what satellite is this. I haven't heard of this.
the Planck
So there's
satellite and the
there's an
WMAP
axis.
satellite.
The WMAP satellite.
Yeah, yeah, it basically shows the background radiation and like it maps the universe. And if you look at
Yeah.
Steve,
What
what's
up?
up, Steve? Long time no talk to.
Hey,
But
I know you.
oh yeah, it's been about 6 months. But I saw you were on too.
I get
I was
around.
wondering where you were hanging out. But
And you had a third reason why?
my third reason is basically dark matter and dark energy being a medium in space that is used in order to create what the computer models showed the universes we're viewing should be doing as far as spinning versus what we're actually realizing, like what we're seeing. So needing that level of extra gravity in space in order to make galaxies spin the way we're seeing them based on the heliocentric model. Um, Adding that medium basically would affect light. And if you're affecting light, the Michelson-Morley experiment wouldn't work the way we say it does. And I don't see how you can remove one type of medium from space and say it doesn't, if there is a medium there, it doesn't affect light, and then put another medium back in space that is based on gravity, and we already know that gravity affects light.
I would say virtually none of that made even the slightest bit of sense.
Yeah, what?
I don't
Okay.
know.
Okay.
I understand
let's
words,
bring it back
not how you put them together.
Bring it back 100 years, right? A little over 100 years.
And light doesn't require a medium because light propagates its own medium.
Not saying it does.
The Michelson-Morley experiment demonstrated that we couldn't detect any ether. Ergo, we used a more parsimonious explanation of things, which is special relativity, which works.
No, you're jumping ahead. It showed.
If I'm on the inside of a sphere, the cell Earth theory, this is what you're calling.
I don't believe in a cellular Earth either. No.
Well, you said you were on the inside of a sphere, right?
Yes, but it's not cellular Earth at all. It's an infinite space going inward versus infinite space going outward. It's an inverse universe.
What is the geometry of the Earth?
The Earth would measure gravitationally as a globe. It would measure almost flat with anything you would use as far as light. And if you did have to model it in like a 3D model, it would look concave.
So we're on the inside of a sphere.
Yes, but gravitationally, it's still a globe.
I don't know what you mean by gravitationally.
These
are words
Okay.
that don't go together.
Okay.
I don't get it.
Well, that's kind of the thing. I'm saying if you took what you see as the core of the Earth, the very center, right, that last atom of the Earth, and you say that that's in a space gradient instead of space time, and you say you're going from 0 to infinite, basically, right?
What's the
Every
space
number in
gradient?
between.
What would be the gradient? What are you measuring? What are you measuring the space concentration in?
It's a matter of saying the way we measure right now, right? Like geometry, we're measuring three-dimensional things, assuming that all planes are equal, but it's just an assumption because the math is actually done based on 2 dimensions and then making another plane that's on a different.
Well, you have non-Euclidean, you have Euclidean. Are you staying
Right.
within
it's
Euclidean math? Or are you staying within non-Euclidean math?
It is non-Euclidean, yes.
Okay, then obviously a triangle is going to have greater than 180 degrees if you add up all the angles. So you're going to have more of a hyperbolic aspect to it.
And if we're
what I'm saying is all things in it that you would use to measure it would be doing the exact same thing,
right?
Whether it was light or a ruler. So there's no way of showing it.
No, because we're living for our frame of reference. We are looking at something. We are not moving relativistic speeds. We have nothing to do with special relativity because we're not moving fast enough to even have Lorentz contraction or time dilation.
Okay, you're going. No, this stuff is you've already jumped into stuff that you have to assume is there because we're on a globe, which I'm not going.
No,
I
don't assume.
Let me back it up to the point he asked me before we get into your stuff on this. What I'm getting at is right now, the heliocentric model has dark matter and dark energy. It is a medium in space, basically, that they are saying is there.
No,
they're assuming might be there. Is a theory of what might be there in order to show an X factor, in order to make what we thought we would see galaxies spinning like versus based on the mass of those galaxies, what we're actually seeing. So they're saying the theory is this is in space. We need an X factor in order to make the computer models match what we're actually
Yeah,
seeing.
you're trying to make dark matter luminescent, luciferous ether. You're trying to make it into Lorenz's ethers. What
I'm
you're
not
trying
trying
to
to
do.
make it an ether.
Well, you
What
are.
I'm saying
But that's
it has
you are.
gravitational properties, correct?
Hang on. You be honest. You're trying to make dark matter into.
I am being honest, so don't call me a liar. And I know you didn't say liar, but when you say be honest, that's accusing someone of lying. So
No,
you're
it's
not the
not.
left
It means you're not actually being honest with
I'm
yourself, and
being
maybe
honest.
not directly
Yeah, I don't need that.
answering.
Hey, you know what? I'm talking to them. If you came here to interrupt me on it, you're doing a great job. Let me finish.
Yeah.
Let me
Wait.
finish.
Let Steve speak. Let him speak. Let him be heard.
My question again is: are you trying to make dark matter into a type of ether?
I'm saying that if dark matter has gravitational forces, we already have shown that gravitational forces affect light. And if gravitational forces like dark energy and dark matter are everywhere and would affect light, then you've already shown that the Michelson-Morley experiment, which is based on light and how it would be affected if we were moving through something that would do that, would show that we are not on a moving object.
Okay, you completely dodged my question. You answered nothing relative to what I just asked you. I asked you, and I'll ask once again: are you trying to make dark matter into ether? Because ether is the medium by which light propagates through. The fact that we have space-time that is curved and that light will bend
That's not a
because
fact. That's not a
it
fact.
follows a natural geodesic path between the shortest points of two curved space. I am asking you, are you trying to replace that and say dark matter is a type of medium? It's a yes or
I'm
no
saying,
question.
yeah, basically, because it has, even if it's
Okay,
only
thank you.
shown
That's all you had to
gravitationally, not
answer.
that it's a medium for light to travel through, which is
Okay,
what you're asking about. I'm
right.
not
And
talking about how it propagates through space whatsoever.
okay, here's the problem. Dark matter has no interaction with normal electromagnetic radiation. Dark matter exists as a form of gravitational force. It exerts a force on space-time, which we would expect if dark matter is matter, meaning it's made of mass. So everything you just said makes absolutely no sense.
How do you know what you just said right now? How do you know that that's what's happening with you?
Does anybody not understand what I just said? I can repeat it. Dark
No,
matter.
I understand what you said, but you said you knew. How do you know?
Because dark matter is a type of matter, thus the name dark matter. We can show that matter produces a warping of space-time.
Okay.
We could experiment with this and say, okay,
Now,
let me look at a
so
star.
if it's matter, right? Matter in space. It's dark matter in space. And
It's regular matter is like anything else. It just doesn't interact with anything
And it
very
doesn't produce
strongly.
photons. It doesn't.
but it interacts
Although
with
it does have, like all matter, it has a gravitation. It has, if you get enough of it, there are gravitational effects, and they have seen it, the results of that.
Correct.
On the scale of galaxies.
Now we're saying that this matter, which has gravity, its gravity does not affect light. Is that what
But
I mean?
dark matter, of course, affects light.
Okay. Now you're telling me, even with it affecting light, if we are a ball traveling through space, the Michelson-Morley experiment wouldn't show that there is something we're traveling through that affects light. Why?
You again, dark matter and ether are two different concepts, and you're sticking them all together, which I know some people have tried to do. Flat earthers have done that or tried to do that.
So you tell me why I should think that it would not affect light if it has
Because dark matter is not a medium.
So
A medium is by which something a wave propagates through.
Right.
Okay, you have to have a medium to have that type of wave. For example, an ocean wave. The medium is the ocean.
Everything
you do not need any medium for light to propagate because it produces its own medium as it travels.
That is based on a theory of what we think is going on.
Yeah, and if you could disprove that and win a Nobel, that'd be great. But you're just throwing out words that mean nothing right now.
I'm saying it isn't even proven. So disprove the non-proven.
So you're asking, wait. You just said it's not proven. Do you understand that no scientific theory is ever proven? You're asking for an impossibility. We don't prove scientific theories.
No, but what you're asking is an impossibility because you're asking me to disprove something that's never been proven.
You just asked me to
prove unicorns. You just asked me to basically disprove.
This is where science fails people in the flat Earth community and this kind of stuff. Let me explain this very quickly. A scientific theory is a confirmed model, meaning that it works experimentally. It works under any condition that it's applied to. It works to describe our observations, and it makes predictions. It's never proven. There's no such thing as a proven scientific theory ever. The law of gravity, not proven.
Exactly. I agree. That's what I was getting.
So here's the thing. So here's the thing. If it works, then we use it. You're saying basically, here's something completely different that we have no idea what you're even talking about because it doesn't make any sense. And you're saying you're right, but you haven't demonstrated anything.
Then it's good. But I'm saying the model to me is not accepted. And I'm saying, guess what? There could be another factor that is.
There could be flying unicorns on my butt that cause light to do it. That's not parsimonious.
Right? The light goes through a medium, right? Everywhere else we see it. On every other aspect, like water. No.
There's no medium for water. This has been this is resolved back in the 50s, and why flat earthers keep bringing it up is beyond me. It's not even a contested thing in science or physics any longer. They have to have this because they want to try to convince people the earth is flat or geocentric, but it's complete nonsense.
I'm not saying it's even geocentric. What I'm getting at is an inverse of a geocentric model. Okay, I'm not a geocentrist. I think the center is the universe.
What is
infinite.
The inverse of a sphere would be the inside of a sphere, right?
I'm talking the whole universe, not just inverting the Earth. Invert everything we know of.
Well, then that would mean the whole universe is in the center.
Yes.
Sure, right. You can do a Galilean transformation. You can make any point the center you want. Big deal. That's all mathematics.
Okay, but my point is mathematically, you can't disprove that.
Well, why can't I see China then?
I could make me the center of the universe.
If you were looking into space, you would still be looking through an infinite amount of space before you would see China.
Do you understand? Do you understand? There's no preferred frame of reference. I can make myself the theory. I can make myself the center of the universe mathematically. It doesn't necessarily mean I am the center of the universe because you can only have one absolute center, right? So if I make myself the center and you make yourself the center, which one of us is right? Well, mathematically, we both are.
We're the center.
What?
Well, wait.
I'm not saying we're the center.
We could be mathematically.
Well, see, correct. I'm not. Okay, let's back it way up.
Okay, I don't understand something
flat,
that
right? Because we see two poles, and I say, okay. So then geocentric models showed up, and they go, why did we get rid of geocentrism for heliocentrism?
Because it's easier.
No, it's not because it's easier. It's because we saw there was retrograde motion of planets, right? Is that why we changed stuff? We said, hey, this works a lot better if we
we understand retrograde motion of Mercury.
Do something else.
But look,
I'm saying we can go on something else.
Have you ever seen
it? It works way better. As far like immediately, you still.
Have you ever seen a top-down model of the heliocentric model versus a geocentric model?
Yep.
Okay, which one is far more parsimonious?
But the point is
no. Answer the question, please. Which one is more parsimonious?
I'm saying the heliocentric model fixed problems that we saw with the geocentric.
Okay, so which one is more parsimonious?
No, dude, you're getting too fat on the words. Bring it back to.
Okay, I don't know why people can't answer yes or no questions. It's either yes, it's parsimonious, or it's no, it's not parsimonious.
He doesn't know what parsimonious means.
Oh, okay, that's different. Parsimonious. Yeah. Which one do we use to have less assumptions? Which one is if we have two equally explanatory things and one uses less assumptions and it just makes it easier? Which one model should we go with?
Just the map of the solar system only.
Just looking straight down using a geocentric model to explain the orbits if the Earth is in the center as compared to if the Sun is in the center of the solar system.
But we're just talking only our solar system?
Yes.
And I will say heliocentric.
Correct. Right. And if you look at the geocentric model, it has epicycles and it's really, really confusing. Would it work mathematically? Sure. But does it adequately describe how planets actually work? No. Because we always go by the barometric center or the barometric center, correct?
What we're doing, so sure.
Okay.
I have a question for Ireland. Are you you accept like Newtonian physics and like satellite trajectories and all of that stuff, but you're just saying we see it all different, like it's different from how how the math is? You're saying it's something different?
It's the inverse. If you inverse what we think is going on, it's exactly what's going on.
Right, but the way we think it's working works. But you're just saying that's wrong, even though it works.
I'm saying the people who did this originally, like in the early 80s, said there's no way at that time that there was any way to determine if you were on the inside or outside of a globe once you inverted the entire universe like this. Like no mathematician could show anything against it. The only thing you have is what evidence do we have? And they said there was a guy. I can look up his name real quick.
Well, there would be some problems with that model, of course.
Well, I mean,
Why?
if he's proposing that there's like stuff we don't understand about space-time and black, like dark matter and like all this other stuff, like I mean, he's like I don't know, like maybe he's proposing there's stuff we don't know. Fine, but I mean, like even if that's the case, like the pragmatic approach is to look at the Earth as a globe and continue to do everything that we're doing now.
Well,
right?
The pragmatic approach would be to do both. You would say, okay, there's a lot of people who are going, we have some issues. We don't know why this satellite data looks like this. Like,
how do you explain the sun?
in what regard? It's still inside the Earth. It can still be 93 million miles away for all of it.
Brenda, I think in his view, you have to throw out geometry because he's looking at things in a completely
mathematically.
The sun is 93 million miles away.
Mathematicians actually wrote this originally.
If the sun is 93 million miles away from me, and then the opposite side of the globe from where I am would be 180 million miles away.
Yeah, no, but Brenda, no, that's like what he's saying is
I'm talking like, think like Doctor Who. It's bigger on the inside.
No, that doesn't make any.
Well, it doesn't make sense, but
it's not intuitive. And intuitive.
He's saying our perception is wrong. What he's saying.
So there's entire galaxies and galaxies of galaxies and superclusters of galaxies.
Yes,
infinitely, and they're all within a sphere that is 26,000 miles in diameter.
No, it appears to be 26,000 miles in diameter, but it isn't.
The way to put it is if you took a line, you just drew a line, and you put a 0 and an infinite, and you said, okay, 1 is the largest number, right? 1 will be the biggest thing you could possibly have, and it'll be the very first, and then
not if it's infinite.
Smaller, 3 is smaller, 4 is smaller. Like the total of one thing will always be bigger than the rest. Like, and it's not a matter of items, right? I'm not talking 1 atom versus 2 atoms. I'm talking in this location. Location 1 is the largest location, but location 1 can only hold 1 atom, but it is the largest location. And once you put 1 atom there, and then 2, and then 3, and the number 2 can hold 2 atoms, but it's a smaller location. And eventually you got going closer and closer to a singular point of infinity, but it's a line to start. Then you draw it as a circle, and infinity's in the middle, and you got your 0 on the outside, which is outside of the Earth.
But you stopped making mathematical sense there.
He hasn't made sense yet. I mean,
no,
it's not intuitive. I understand that. The reason flat earthers believe in flat Earth
it's not
intuition.
It's not even about that. It's just what is the point? We have working model and everything
we don't have. I disagree that we have a working model.
Well, I can tell you right now we do. Yeah, what is there? What do you disagree about? Because I don't. Hang on, let me answer this real quick. I know a lot of people that are into astrophysics, a lot. And I guarantee it, if any one of them, including Dr. Hugh Ross, who's an astrophysicist and who I talk to frequently, if he thought there was a problem with the model such that the model wasn't the case and the special relativity or general relativity was wrong, he would be the first one to go, hey, let me try to show this and I'll be famous.
If he knew why it was wrong, sure he would. But
so
maybe he doesn't.
Can you write down in the physics and the maths why it's wrong? And I'll be happy to submit it to him. He'll look it over for me.
Yeah, I just want to know what's wrong with our model. What is wrong?
Okay. Like I was stating before, the 3 major things I have is first, satellite data makes it look like the axis of evil is pointing at Earth or our solar system or whatever you want to call it.
Can I refute that? Because that's not true. That's absolutely not true.
That was going to discuss
the axis of evil. What are you talking about?
I don't know what he's talking about either.
It's about the background radiation.
This was. You want me to explain it to you? This was. Yeah, this was something promulgated by what's called the movie they call The Principle. The axis of evil was an actual thing on the cosmic background radiation sent by the Planck satellite for the WIMP, was basically based on the WIMP data, weak interactive massive particles. And this map that they showed that some of the monopoles, which is the alignment of the particles, tended to have a specific what's called anisotropy. And they said that this pointed directly to the Earth, which is not true. It's actually 10 degrees off the elliptical center, so it's nowhere near our solar system. It's like saying, hey, Shar, point to Mars, and you put your finger up, then you go, okay, it's over there somewhere. Yeah, you know right now if you drew a straight line, it's not going to Mars. You're way the fuck off, right?
Right.
It's something like that. It's 10 degrees off. And of course, this doesn't work for them. They have to they want to say, no, we have a unique place in the universe. This axis of evil is directly pointing to us, indicating that clearly we're unique, because what's the odds of that doing that? When it's not directly pointing to us, you can look at the monopole data. It's clearly not. And yet the movie The Principal ran with it because these are actual geocentrists by the name of Wyatt and Sunjits, who I've spoken to both of them on this. They're very dishonest. So yeah, Ireland, I can refute that in depth.
I suggest that everybody watch that movie and realize who is
watch it and realize it's
that
wrong.
very issue, and which of these astrophysicists are being interviewed and talking about it, and why they find it so weird.
Well, no, it's weird because we weren't expecting to have anisotropies such to the degree that they are. It's not that large. Matter of fact, the variance of the cosmic background radiation is minuscule. It's 2.725 degrees Kelvin, plus or minus 0.000 something. Very minor. But when you get down to that kind of resolution and the technology we have, we can show that there is some kind of fluctuation delta in the T. And that was a little bit unexpected because we expect a little bit of homogeneity in the universe. Not a big deal. It can be accounted for by the lambda CDM model. It's not something that turns science on its head. It's interesting, but it's not something that's completely a violation of what's called the Copernicus principle, right? That we have no unique place.
Principle?
Yeah, that we have no unique place in the universe. But they ran like this because they have been promoting this stuff because they think
I
the
know what
Catholics
they were
wrong
doing, and I'm not a geocentrist, so...
You just said go see the movie that promotes geocentrism.
No, I'm saying they should see it so they can see what these guys
called The
actually
Principle.
said about it.
The whole movie grossed $87,000. It was a total.
I don't care if it grossed $1. It doesn't make it any more.
And what's worse,
$1 billion, it doesn't matter either.
They actually got Kate Mulgrew, right? The Jane from Star Trek, and actually the one that's in Orange is the New Black, Lover. They got her to narrate and did not tell her what it was about. And when she found out about geocentrism, she had a conniption fit. So did Lawrence Krauss and a few other people. They all interviewed, and every person they interviewed said they were not told what the movie was about.
Why should they be though? They just said, "Hey, talk about this."
Because because a lot of them were speaking very generically, and they were cut and they were edited. It was a very deceptive movie. And anybody who knows anything about physics or astrophysics would know instantly that this was a Frankenstein movie, meaning that they took cuts and they spliced them together just like Ray Comfort did. And it has no evidence in the actual science. Go look at the actual science. Go look what I just told you guys.
They were trying to go for geocentrism. I fully
understand. Yes, they are.
I didn't agree with what they did about it.
All about geocentrism. Are you kidding me?
I understand.
For decades.
Look, I understand that that's what their goal was. I do not have a matching goal with them. I'm saying just look at the footage of the actual astrophysicists and what they say.
And every astrophysicist said that they're wrong after they've seen the movie. This is bullshit, they said. Every one of them have said they.
I know, it's amazing when they actually just talk openly and honestly.
Don't lie.
Now it's going to scientific conspiracy.
Clips of them going, "Hey, here's what I think."
You don't have to be a scientist to understand this. Go watch the movie and go look at the science, and you understand what Ireland's telling you is complete bullshit. It's not that hard. Look at let's look up anisotropies of the cosmic microwave background radiation.
Don't lies matter to you, Ireland?
Dude, first,
no, doesn't lying.
Well, Ireland, you made a statement. You gave number one, and
hey, you know what? Stop interrupting, dude. I came on here to talk to these guys, and you just talked over me as fast as you fucking can the whole time.
Well, you don't answer any questions.
Really pissed at you, dude. You're being uncool, flat out uncool. If you want to have a chat, we've chatted before. We've had ones where we fought before. We've had ones where we've been cool before.
It's really annoying.
Man.
I understand, but it's really annoying.
I don't need to be attacked. I know you are emotionally attached to atheism.
No, I'm not an atheist.
The geocentric model is needed.
I'm not an atheist.
All right. Stop. One of you guys talk, And then when you guys finish, and then
Give
when
me
you
10
guys talk
seconds.
afterwards.
I am not an atheist, and you prey on the fact that people don't know basic science, or this is a little bit more complicated science. You made a statement very clear: the axis of evil demonstrates your case, and I explained to people the actual thing that you didn't, because I don't think you understood it well enough to.
Unexpected. It was one of a few things added together equal. Here's my case against why I think heliocentrism is not working out. And
Okay,
you want
and I
to take
explained
one, and you're looking at one leg of a table that has three legs.
I just
On it. This doesn't hold up a table.
Okay, I just destroyed that domino. The axis of evil. The axis of evil is 10 degrees off the elliptical center. It doesn't point to us. There go. It's not a big deal. Big deal. Move on. I mean, there's no sign. Yeah, there's nothing. There's no evidence for it be any kind of violation of the Copernicus principle.
I didn't say it was a violation.
That it's not evidence for a geocentric universe.
I'm not trying to say it's geocentric either. I have no. My model has the globe on the outside, not the inside. It is not.
So what is the axis evil evidence for?
I was only stating that this was very unexpected for all these heliocentrists saying this is what this makes us. Cross actually said, you know who Cross is? I know you know who he is. Astrophysicist in that movie said this makes us rethink the Copernicus principle. Like, is this him coming back to bite us in the ass?
Yeah, and do you know what he meant by that? Because what is the Copernicus principle?
It's about the randomness, right? Or not random, like nothing special. Sorry, nothing in space.
Yes, we have no special place in the universe.
Right.
Right.
And he said that. And
then they found out it doesn't violate it. So no, it's not Copernicus coming back to bite us. So that's what I'm saying about the deceptive aspect of these types of discussions.
Weird. And yeah, I know.
I put a link on the side chat there. That is the paper written about the data that came out, and it discusses the anomalies in detail. And I haven't read it yet, but I will.
Yeah. So the point being is what he's saying is completely wrong. The axis of evil does not point directly to us, and it doesn't violate the Copernicus principle, like he said. He even said it doesn't violate it.
I said our solar system, our neighborhood, whatever you want to call it. I didn't even say it violated it. I just said.
Then how is it coming back to bite us?
Astrophysicists say, "Hey, is this coming to bite us in the ass? This is weird. We did not."
And the answer is no. So now we know the answer is no.
Well, you can probably call all those astrophysicists, or at least the ones you know, to call them and tell them that the answer is no, because they've all gone on record. Every one of them is in this movie said, "Yeah, this is complete bullshit." They've all said there's no evidence. Now you're misrepresenting. They didn't say that about that data and what they said about that data. They said it about the movie was bullshit.
But do you understand how? Go ahead,
they determined that the impact of the anomalies is very small.
Yes.
Yeah, that's the ultimate determination. Yeah. So, I mean, I'll read the paper later, but I don't think there's anything there.
I got a question. Did anybody else lose the connection? I lost my connection briefly. No? Okay.
No.
Ireland. Why? Yeah. These people that you're citing in the principle, right?
Mm-hmm.
The people who made the film lied.
Yes.
Right?
Yes.
Wait. I don't know if they lied. Steve's assuming they did. They just said we're making
the movie. They did. I could demonstrate it. I've talked to them.
Wait, stop, Steve, stop. What happened to that whole I'll talk, you talk, I'll talk, then you can say whatever you want about it. Don't say that I'm assuming.
I could demonstrate it.
No, what I'm saying, no. We do not know that they lied to him. They might have said, "Hey, we're doing a movie."
That's not how they lied. That's not how they lied.
Okay, how did they lie?
How do you lie with film? The way you lie with film is you film somebody, you interview them, you talk to them, and then afterward, in post-production, you cut up the words that they say. They said into bites that fit in ways. Excuse me, I'm talking. Into ways that fit your narrative and that misrepresent what they actually said.
Right.
So that's lying. Okay. That's how filmmakers can lie.
Yeah.
Right.
How they
you see it. For example. Have I seen what?
That movie.
No. Should I?
Then how do you know that's what they did?
Because I've seen it, and I've talked to the producers of it directly. Go look at the video. Go look at when this movie came out on YouTube. I have long discussions with that particular video on YouTube with Wyatt, one of the guys that produced it from Bob Sunjidis.
Well,
The
it's not
reason
like
I-
Robert Sturgis.
slashed
The
and
reason-
hacked. Like, you guys
the reason
talk
I
about
haven't
it
seen-
chunks at a
yeah.
time.
The reason I haven't seen it is because the people who were interviewed in the movie say that the producers of the movie misrepresented them. And so
Yeah,
because the producers were dishonest, it leads
I don't
me to
think they
think that they are not.
misrepresented anybody.
Well, you know what? You can claim that all you want, but the people in it, when you have when there's smoke, there's fire. When everybody in that movie said they were misrepresented, come on. I mean, with Kate Mulgrew, even she even said she was paid to do a narration. She had no idea, was told what it was. They have to give the money back. Come on, it was completely duplicitous. It's something like Kirk Cameron and Ray Comfort would go do. That's why it only grossed $87,000. It was a box office flop because people recognized the fact it was dishonest.
So
I
the
don't know
reason
if that's why it's a
I
flop.
wouldn't see a movie like that
Ooh.
is because of that, because reports that it was dishonest. It's the same reason I won't watch other movies that have been shown to me to be dishonest. And so I only have so much time in my day, and I'm not going to spend my time
Yeah.
Well, then you
watching
don't
movies
do it.
that are dishonest.
But I get that. But here's the thing.
I'm not. I don't want to just straight stick up for their movie or not stick up for it. You're trying to. This is like getting us completely off track. I'm only
Okay,
saying
right.
there
Let's
are
look at the
huge
data.
chunks in that movie where these astrophysicists are saying things that are coming out of their mouths. Fuck the rest of the movie. Fuck their stupid
Well, no, that's
digital
just
bullshit in
That's what
between their
Frankenstein
narration.
cuts are,
whatever.
taken out of context.
that's
I'm
editing.
saying,
That's
That's
editing.
get
I can
back-
make.
Right.
We could make you
Look,
say
I'm
anything.
saying,
We could
here's
make
the
you
thing,
say
here's the
anything.
thing.
Here's the thing. Here's the question. Okay. And by the way, see, this is why Wayne does invite people like myself and Shar, who's experience in sciences. That because when people bring this stuff up, most people are going to be like, I have no idea what he's talking about. And they just think they can walk over people. Here's the thing, Ireland. You find me any physicist, any one of them as a physicist, besides one that I know of, and I'll explain to why he's wrong in a second here. But you find me one with a PhD that is willing to go on record to say that movie was correct or anything that they stated was
No.
correct.
I'm not defending
No.
the movie. I'm saying if
No.
you take
Okay, so
all
you're admitting that no
what
scientist
the
would.
astrophysicists
There you
say in the movie and throw away all the rest of the movie, everything else out of the fucking movie. The only thing you're left with is Cross, Kaku, and you edited only that back together.
I'm going to have Kaku
And
on
no
in about.
other shit.
I'm going to have Kaku on next month, and this is one of the
Good.
topics we're going to be bringing up. Hopefully, I'm trying to get Kaku on next month.
I hope you get him because I think that guy's
But
full of
here's the thing.
shit.
Here's the thing, Ireland. Again, are you saying that any scientist would go on record right now and saying that
I'm not saying that. You putting words in my mouth? Yes.
I'm asking you a question. So how can I put anything in your mouth? I'm asking you a
Trying
question.
to.
Would you say that any scientist with a PhD in astrophysics would say that the axis of evil somehow is evidence against the heliocentric model? Yes or no?
I have no idea. I have not interviewed.
Well, there you go.
every
Then you have no case.
physicist out there.
You don't
That's
know.
a
You
dumb
can't make an
question.
argument about it. There you go.
Did you ask me a dumb question? Yes. Whatever.
How is that a dumb question? Because I can tell
Because
you.
you already
There's
know I'm
only
not
one
out there
there's only
asking
one
every
astrophysicist.
astrophysicist on the planet this question.
Do you know any?
So how could I possibly answer
Do you
it?
know
Have I
any?
ever tried to know any? No.
All right, so you have no evidence that the anisotropy gives evidence against a heliotropic nature model. There's one astrophysicist that actually thinks in a geocentric way, and do you know what his problem was? Wait. No, let me finish. He's one of the scientists that they used. This guy was so dishonest, and I can show you why he was dishonest. He actually used a three-body. Sharp, you remember this from your vector physics. He used three-body system, and he took two orthogonal vectors, and he did a dot multiplication, and he came up with 0. And he realized, oh shit, this is going to fuck all my math up. So he converted the vectors into scalars. Char, what happens when you take two dot? If you remember, what happens when you take two vectors that are orthogonal and you do a dot product with them?
Well, you
It
lost
goes to
me.
0. It goes to 0. Okay. Now, what happens when you have division by 0?
Well, I don't think she could even answer that question, but you answered it for her. Make it seem like
Yeah, I don't quite. I barely remember that.
Well, you know what
It
happens with
makes
division
sense.
by 0, right?
Yeah, of course.
Okay. So that's why his paper. I read his paper and I was like, I mean, it was you could tell in the third. I think it was the third equation that he had converted the vectors to scalars, and he copied from somebody else. He plagiarized from somebody else. So yeah,
I'm confused about something about Ireland's model. So at in the evening when the sun goes down, I see
where does it go?
the disk of the Earth is partially, I mean, the disk of the sun is partially occluded by what appears to be the Earth. And you're saying that we're on a concave surface, and
Let me put it like this.
I don't see how that works.
Okay, I know it's hard to wrap your head around, but I'm saying in this model, you can even see a globe shape, a globe of the Earth, transit in front of the sun. If you were in the right spot in space, you would think, I just watched a globe go in front of the sun, even
I
though the
just want to
sun
know.
is on the
I just want
inside.
to know what's happening optically. I'm standing on the Earth.
Okay.
The sun is some distance away, and I
Yes.
only see half of the disk. It's going down. Why can't I see the other half
The other half of the Earth.
of the sun?
If the sun, you're saying the sun's on horizon.
Yeah, it's on the horizon. It's
All right,
going down. I can
So
see.
you're like, why can't you see the back of the sun at it? Like, why wouldn't it light on that
I'm
side?
sorry,
Because okay,
what is obviously something is between me and the lower half of the sun. In the round Earth model, it's the Earth, and in your model, you're saying we're on a concave rather than convex surface. What is coming between my eye and the lower half of the disk of the sun?
let me bring you up a picture of it so you can get an idea of what's.
Oh, we like pictures.
You'll get a picture.
This is why I like to keep things rather simple.
Well, no, I get that, but sometimes they do try to throw in more complicated.
His model is not simple. That's the problem.
I'll leave
his
the
model's
complicated
untenable.
stuff to
It's not
Steve,
simple.
and I prefer the simple.
I think
Waiting for a picture.
I'm bringing it. Hold your horses. Let me get to Sharon.
Would this explain anticorpuscular waves as well?
You mean rays?
Oh, what did I say? Wave? Yeah.
Yeah, you said waves.
Well, sorry.
You do sometimes talk faster than your brain can engage sometimes, Steve.
Anticorpuscular.
Okay, I got a picture.
No, I agree with you on that.
Give you a rough idea.
Well, you know why that is, Brenda? Because everybody tries to talk, and I have so much to say, and so little time to say it.
Okay.
JD gives me like what 3 seconds in talking shit Tuesday. It shuts me down.
Yeah, he did. I have to be fair. He did shut you down.
I know he's done it to me quite a lot lately. Even I've asked him about that. He's like, "Oh, I don't mean to do that." Well, okay, but you do. Go ahead.
Okay, so the sun is there. Is that yellow dot? I'm standing on the surface right there in the middle.
On Italy, yeah. Whatever it says.
So I'm still not understanding why I can't see the lower half of that sun.
Okay, do you see the arc of slightly yellower coming on?
Yeah. What is that supposed to be?
That is the daylight. You can see my mouse going over. Actually, let me jump to the other page. That's it.
I don't see your mouse going over it, but I understand that that's yellow.
Okay, so this is basically light. Light is bending due to all the rest of the universe being here, right? Exponential increase of distance. So your light is actually doing this all the way through. So if you were here and you saw light, like what you would think is up, it would be bending.
Yeah, I understand that part.
So
Okay.
here's your horizon, right? Like if you're watching, if this is going, let me see which way he drew this before.
The horizon would be the top of this circle.
Yeah, so this is your sunrise, and that would be your sunset, right there.
I'm not seeing I'm not seeing a cursor, but okay.
Yeah, but so wait a minute. So if I'm looking at this correctly, and I think I am trying to. If I'm standing at the bottom and I'm looking at the sun going on the horizon, and I go 45 degrees away from that, I just look 45 degrees, and I take a pair of binoculars, I should be able to see light that's bending that shouldn't actually be in that actual position.
No, because the light that you're looking at through your binoculars would be bending in an almost identical shape to the light that's being bent from the sun. It would look almost flat. Like
so
you would pretty much,
why can't I see the bottom half of the sun?
Okay, you see where the guy...
Yeah.
Okay, where the guy's standing right there, right? You see the guy?
Yes.
Okay. there's now in India. I don't because you can't see my cursor, but in India,
I
you
can
basically-
I
now.
can see your cursor.
Okay, so right here,
Yes.
this is where the last bit of light of the sun is, right? Like this is the last place that would be seeing
Uh-huh.
any type of light.
Okay.
And then, so this is your half of the planet that's lit all the way
Okay.
from here. Okay,
Right.
this is the half that's in darkness. As that
But
sun
India
orbits,
would only be choking at the very top of that sun. The very vast piece of light is the very top of the sun. That's the last thing India will see. How is it seeing light that's not coming from the top of the sun in your
you
diagram?
mean right here?
No, in
Yeah.
India. Yeah, right there. That's where it'd be coming from, right?
So where's this light is going? All this light's still bending, right? So this light here. Let me put it like this. Your moon's over here. Let's say there's a full moon. You see my little plus sign? Say New
Uh-huh.
Zealand's looking at a full moon right here. It's actually the light here doesn't hit the surface. It's always getting pulled back toward the center. So the moon's front, the moon's here. This light that didn't quite hit the surface of the Earth actually comes all the way back around and hits the front of the moon. Or if it's not there, say that it's doing this, it's going to get sucked back toward the center.
I'm still confused
all
about.
gets
I'm still
toward the-
confused about why I can't see the lower
No,
half
no,
of the
no,
sun when the sun goes
don't
down
either.
below the horizon.
Okay. So this sun comes way over here, right? And this is your horizon line. So you're looking at this here, the last bit of sun finally gets to this horizon. That's
Yeah.
your sunset. Sorry, I'm going the wrong direction for this.
You're not explaining why I can't see the lower half of the sun, though.
Okay. But the sun would be over here, right? Where my cursor is at sunset for you.
Okay.
But any light that wouldn't quite make it to you, it wouldn't make it down. It'd be getting sucked back toward the center. It would miss you and go
Wait,
back in.
are stars? Is the sun a star in
Yes.
your model?
Okay,
So
is it
why do we
93
see
miles away?
stars, and why does the sun not at least appear as a star?
Is the sun 93 million miles away in your model?
It's not exactly for the same as a heliocentric.
Okay,
model,
so how
but
close
it's
is the
millions
sun?
of miles away?
How
Huh?
long? How close is the sun in your model?
It could be. I've looked into what I'm trying to still build this thing because right now this is actually just a thought
Give
experiment.
me an estimate.
that I showed you. What? I'm saying it's millions of miles away. It's probably 50 million. Who knows?
50
haven't
million. So it goes from 93 to half that distance, and that makes a
It
big
could be 110. I don't know because I haven't worked it all out yet.
Okay, can I make a suggestion? Why don't you learn actual physics and science before you try
Oh,
to
fuck it,
falsify
man.
like the greatest model of all time? I know I'm not trying to be disparaging, but look at if you don't know how to make a model because you've never had any scientific experience, then you're not going to be able to do this properly.
Here, let me bring it down to the guy who actually.
You still haven't accounted for
No, he hasn't.
why I can't see the lower half of the sun.
Right, I know. Or
Why?
anticorpuscular ray.
Because the part that would be aiming toward a concave that could hit the Earth in any way would still the stars you would see here. I'll go back to it, right? So let's say there's a star, this star right here, right? And yours.
Well, just explain the sun to me. I don't care about the stars. Explain how come I can see the top half of the sun and I can't see the bottom half?
I think the key in his answer is the word aiming. He's saying that these things are aiming their light.
No, I'm saying that if a star's up in the sky, right? And you go, okay, you're not going to see. How do I put it? If this is infinite space right here, right now your sun's way over here, right? It came to let's say it's going this way. You cut your sun. So here's your sun. It's now on that same arc right here. Now this amount of space just became ginormous, and the light that hit here, any light that didn't get to where your horizon is after sunset, spun back into space. It's not actually getting to
Okay,
any point
so
on
the
Earth that you can
the
see.
sun goes further away from us than our stars. Like
No.
the sun, the sun must have this.
She's trying to tell you is if we see the same problem with the sun, how come we're not seeing light bending from the stars like that?
Yeah,
You are.
I get it.
You are.
We are?
No, we're
This
not.
star is not in this model. This guy here and this star here. If there's a star there, it's not a straight line to this guy. It's more like this with a slight arc going to him. Just like these arcs of the sun, it'd be barely arced. So the only light, the proton that gets to his eye, or photon, sorry, from here
They are
is
straight
gonna.
lines, though.
No, I'm saying it would be an assumption. Any way you would measure this, anything you would try to use to measure this, you couldn't use because it would be bending the same way. It would always look like you're on a globe. It would always look like registering flat
I
light.
think there's a fundamental problem here. You think that if my measuring stick bends, then I can't measure along with the thing that I'm bending. That I can't measure. So if I have a tape measure, and I have a surface that is curved, and I put the tape measure along the surface, I'm measuring it, aren't I?
Yes. Okay. Let me rephrase it. Because it's an exponential increase of distance going from the outside toward the inside. If you were trying to measure directly up,
well, everything increases along those lines, right?
Yes.
So my tape measure would increase along those lines in the same way. So yes, I would be able to measure.
Right, but this sun could actually be right here.
All I need to measure something is a designated length, and I need it to behave in a regular way. And so if the measuring stick that I'm using conforms to the space in which it exists, then it measures it.
What's causing the light to bend in the first place in your model?
The reason I'm saying, okay, we already know solar eclipse, right? Moon goes in front of the sun, and there's stars that we're tracking, and you go, hey, that star is supposed to be behind the sun, but it shows up just on the inside of the moon during an eclipse. This is what we witness this from Earth. We call it gravitational lensing. Well, if you have all that,
it's not, but that's okay. But go ahead.
Bending of space-time, making it happen, blah 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 for the Gloomers. Got it. All right, but we witness this. We observe that basically gravity is bending light, and if you have all of this universe in here, it's being bent. And now this is your globe, right? This would actually be the globe. Like, it's a little Pac-Man-ish, like, because this is the last. It'd still be a circle. It wouldn't be this big square, but if you had a circle going all the way around, that last thing is maybe a few atoms, one atom, whatever it ends up being. We can't drill to the center of the Earth, but that last piece, basically, if you drilled through it in India, you'd pop out on the other side still. So you could still drill.
What is the brown stuff?
Well, let me explain to him what he's talking about, because he's not. Okay, first of all, no, it's not gravitational lensing. Okay, that's a totally different phenomenon. What he's talking about is called stellar aberration.
Sure.
Okay, it's stellar aberration is when you see a particular star that we would expect to be at a relative position to the sky. We see it at a different position because it is the light has traveled around a body of mass, causing that light to bend, like the sun.
Right.
Okay. Right. Stellar aberration, the mathematics we used for that, we could tell you exactly what the subtended angle is and how many arcseconds it's bending by using the mathematics for the model we use, which is relativity, and it'll give us an exact prediction of where that star will be, like you said, during the eclipse. Do you agree with that? Yes or no?
Why? Why does that happen?
Well, hang on. I'm just asking you, can the model tell us exactly?
Because you have something to compare it to.
Okay.
Absolutely.
If the model can tell us that, okay, then we know the model is accurate. How does your model tell us that? If I said, how do we use your model? Give me the math that you use to show me what the actual position of the star is compared to where the star will be relative to our observation. What mathematics do you want to use? Star just put some of the mathematics out there in the group chat. Yeah. So what would you use?
Okay. What I'm getting at is if you have the gravitation of all this dark matter and dark energy in the center of the Earth, and we know that light can be bent by gravity, which you are agreeing to. That is what you're asking me. What the mechanism is? That is the mechanism.
Well, no, I'm asking you what math would you use? Show me how you would go through the process of calculating this. Char showed you how she would do it. Show me how you would do it.
That's been done. Okay.
It's been done.
So. Yeah.
Okay. Well, show me how it's been done.
Okay. Now you see it. Are you able to read this right here?
Sure.
Okay. Now this is that's his picture, right? I'm just trying to bring up this guy's thought process.
Oh yeah. So it's not even your model; it's somebody else's model. Okay.
Yeah.
Okay. No, I was already going with this, and somebody actually pointed this out to me. That hey, guess what? This exists. It was cathexis. Thank you very much if he's listening. But
it was one of the biggest dumbasses I've ever seen on the internet. Let me throw that out there.
That's great, dude. Yeah, anybody I would point out that I would think is Like
So
helping
what is that
people-
brown in that picture? What is that brown stuff all around?
That's just showing.
What is
Basically,
that?
that's the surface of the Earth. That would be the
No.
inside of the Earth, but it's not a square.
Well, hang on, Brenda. I'm still asking. I've yet
Okay.
to see how he would show us using mathematics. How would we know what angle of deflection that star has from the stellar aberration from its real position to its apparent position? What mathematics would he use that's any different?
Okay, now just look. This guy, you know who Gardner is, right?
Yes,
You know Martin Gardner
well familiar with Martin Gardner is. Yes.
debunks all kinds of shit, right? He's Mr.
Yes,
Debunker. He did up until he
he's a
died,
wonderful,
right?
brilliant
So
man.
this is what he put. Most mathematicians believe that an inside-out universe with properly adjusted physical law is empirically irrefutable. There's no way to know, right? So what does he say about it?
Properly adjusted physical law?
Yeah,
Yeah,
because
I know
the
what they mean. I know what he means
physical
by
laws
that.
that
He
we've-
doesn't. But
Yes,
yeah, let me
because the
explain what
physical
the question
laws
is
we
saying.
have are based on our observations.
Yeah. Do you know what Occam Rangers
that are on the
is?
globe.
Occam
Yes.
Rangers is parsimony
Yes,
that I
do.
mentioned to
don't
you
need to
earlier.
know. If you're doing it for the crowd, great.
The Occam's razor is the law of parsimony, which I explained to you earlier. Okay.
Yep.
I said, and I said this from the beginning, we could do transformations, what's called Galilean transformations, to make anywhere the center of the universe. Did I not say that at the very start of this?
You sure did.
Okay. This is all this Martin Gardner's saying as a mathematician. We can make mathematically the stuff work. That doesn't mean it actually works in corresponding to a one-on-one relationship with reality, because I'm a scientific instrumentalist. Okay. But
so
yes,
what I'm
we can
getting-
make mathematics appear to be anything we want about the center of the.
Right. So what I'm getting at is the mathematics we can put aside then, right? We can just put it aside for a moment and say,
No, I still haven't got my question answered, but go ahead.
okay, my point being is you mathematically aren't going to be able to do it. So we're left with, can we show that these are the physical laws going on versus the other? We actually have to look at just the empirical evidence, right? That's all we're looking for at this point for this model.
So,
Wait, I got a question.
hang
before I
on
go.
a second, one second. Wait, real quick. All he's doing is taking one matrix, right? And he's just doing a transformation on coordinates of it to something else. That's it. It's a trivially true. True. It's basically like,
Okay.
look.
My
Hey,
point is,
wait,
you
if
don't
I wait,
have to
hang on,
argue
Wayne,
that
if I
it can be
Wayne, if I Wayne,
mathematically done.
Wait. Let him finish.
Wayne, if I have a matrix, right, and I have a coordinated system, and I say, hey, what's the inverse of that matrix? You could do the inverse matrix,
Okay.
right? I mean, maybe you might have to figure it out, but there you could take an inverse matrix of something, correct? If you had to, if you know about matrix there. Okay. All you're doing is taking the inverse. You're doing a transformation. You're not changing anything. Any model that he's talking about doesn't change the model we actually have. It's just less parsimonious because if we follow Occam's razor. Why?
Okay.
If I say 1/2, right? And then I say, hey, I give you this big old long formula that's huge and unwieldy, and I say, hey, this equals 1/2. You don't need to use all that. You just use the 1/2 because that's
Okay, look,
parsimonious.
I understand, but here's the issue.
Okay.
This came out, right? This guy wrote this in '92. Now, this all came out in the early '80s. Since then, we've had more data collected. I'm saying, since this point, the more data that's been collected points against the globe and
That's
toward
not true.
this.
That's completely wrong. That's absolutely bullshit.
Now, look, I'm just going to go down. It's fine. Call it bullshit. But here's the next thing. Contrary
bullshit?
evidence. Oh, great. Contrary evidence, right? There's a little section on it. Hold on. There's contrary evidence on this page. I want to point it out since I've been showing that it exists. Now, this article right here, it's a Hollow Earth article, right? It's talking about all the different Hollow Earth
This
theories.
is a scientific.
concave
This is a
theories.
scientific argument from Wikipedia. Go ahead.
Right? Okay. What I'm getting at is it's talking about cellular. It's talking about hollow. It's talking about this. Now, this contradictory evidence, the seismic, not an issue on this particular model because it's still a globe. Gravity, same thing. The density,
it's not a globe.
same thing. So the only thing we got is direct observation.
It's not a globe,
saying-
though.
It would act as gravitationally. You would know no difference between it.
Again, but you're Ireland. You're completely missing the
The
point here.
density, the gravity, and the way it works seismically.
I could do
You would
any
not be
transformation
able to
to a
tell the difference.
system as long as
Agreed.
Okay, then why is your model any more effective when it makes it far more complicated to get the same results?
Yeah, I think
I
it
know
goes
what you're
back to
getting-
my original question.
what?
Like Like, what is the
I don't
point
think
of
it
all
makes it more difficult because you don't need to do things
Of
like
course it
special
does.
relativity and space-time and all the stuff that Einstein said this is
But
what
no, you
has to
still
be
do.
happening
No,
if we're on a globe.
But
Just
how would we
absolutely
get
not.
satellites to work if we didn't do all that stuff?
Yeah, I mean,
Because-
seriously.
Like,
Yeah,
like
Why
would we
am I
this does not eliminate special relativity or any of that stuff. It's just a transformation. It's a mathematical game. That's all it is.
Okay.
does Steve
But
does it
We
explain
would
does
no
it
longer
explain
be orbiting the sun, right?
No, we would still be orbiting the sun. We're just looking from a different transform, an isomorphic transform based on Galilean transformations. It's just numbers. That's it.
Just numbers.
Hey, Ireland, before I
Call
go,
what you will. This is what I think is going on.
Ireland, I got a question for you. What's your theological position? I'm interested now.
I don't know. I guess you would call.
Is your theological position as complicated as your science?
No, I mean, I look at it like, I guess the weirdest way to put it is like this very gradient that we would see from nothing to infinite would be like, I believe, like, how do I put it? Heliocentrism to me, the Big Bang, all that stuff is just another form of creationism. It's something from nothing.
No,
It had to have been created. It got made. I'm not saying a God did it. I'm just saying
No, that's not what Big
something
Bang is.
came from it. It has a start. It has an end.
What is it?
This just says it is.
Ireland. What does
there
the Big
only
Bang? What does
the
the Big Bang
is.
have to do with creation? What does the Big Bang have to do? What does the Big Bang have to do with the origin of the actual universe, the cosmogony? What does the Big Bang have anything to do with that?
Guys, I'm making a sandwich. I'll be back.
Make one for me. I want one too. Yeah, I'm trying to understand here. How are you relating Big Bang to the origin of the universe?
Give me a beer. 'Cause I need about 2 or 3 of them right now.
Oh fuck! I need that 10.
The Big Bang has absolutely nothing to do with how the universe came.
Okay, why do we believe there's a Big Bang? Because
no.
redshift.
I'm asking you a question. Why do you ask me a question when I ask you a question? What is the Big Bang?
I'm just trying to explain
Okay,
why I get to this.
What is?
Because we need the Big Bang theory on the heliocentric model to explain how the cosmological redshift, which is claimed to be happening by Einstein, for it to be existing, our best theory for that on a globe is the Big Bang. Am I incorrect in that? Is it better theories?
But that's a lot of other things you got. Okay,
Wait,
again,
it's not cosmological
very
redshift.
basics. Let me start from the very basics.
You're telling me not cosmological redshift.
No, what I said is not okay. There's a difference between cosmological and cosmogony. But Big Bang is not cosmogony. The Big Bang does not have anything to do with how the universe came into being.
Right, you're talking inflationary periods.
Yes. Okay.
Yes.
So now the Big Bang model was predicted, and it was said that if we could find a cosmic microwave background radiation at the temperature of 2.725 plus or minus whatever it was, then that would be indication that the model is correct, because that would be a very, very specific prediction, which we discovered in 1964. Would you agree that was a very, very specific prediction?
Ooh, I guess the way to put that is, if the thing always is, like, imagine this model exists and all of it's always inside of this and there is no start or end point, wouldn't we expect that anyway?
No. Again, why would we expect a 2.725 Kelvin background radiation? Why?
You're talking about how little it would be.
Why would we expect that specific number? What does that number represent? What is the cosmic microwave background radiation? What is that? Why does that validate the Big Bang theory?
Well, the reason they say it validates it is because we all had to have been together at one point for it to have spread so equally.
No,
that's saying, what if it never had to spread at all?
No, first of all, it's called the cosmic horizon problem. Completely different thing that you're conflating.
Right,
that has nothing to do.
Whatever. That's why they came with inflationary theory to show how it happens.
But that's a different. Okay, but that's a different thing. I'm not asking you about the horizon problem. I'm asking you about what is the cosmic microwave background radiation.
Why don't you tell me all about it? If you got something to add it. You don't have to.
You're making the arguments. You're saying that your model's better. I understand the model we have. And I said to you, why don't you learn the correct model so you can understand the sciences first? You said you don't need to. Great. So explain to me what the cosmic microwave background radiation is in the model that we use, which is the Big Bang model, why it's what it is, and then what it is in your model. Do a comparison so we can compare and contrast. That's how you do things, right? You guys want to hear that? I do.
Sure, let me just whip that out right now at the drop of a fucking hat, all right? Yeah, that ain't gonna happen when you know it. This is why
I can do it. I can do it in 5 seconds.
Of course you can, because you've already done it 10 other times.
Because yes, and you haven't. That's the point. This is why
why don't you just say that in the first place and instead of trying to, oh, look how sneaky I can be. You don't do this right. Because
I'm not going to be sneaky. I'm demonstrating that if you don't know the topic, how you ever qualify to say this model's better? You don't know what the actual model uses. If you don't understand Big Bang cosmology, how the hell are you qualified to talk about it? To say that's wrong.
I'm only stating that it's complicated. Very fucking complicated. And we were talking about Occam's razor. Use whatever's the most simple, which is what you were talking about right here. See it?
Well, yeah, but
and you go, look,
no.
why wouldn't you just use the first of all, with the globe? The globe ain't that fucking simple, is it? Because it's really fucking difficult, and you just
Occam's razor, the law of parsimony, is not to do with complexity. It says that if you have two competing hypotheses, you choose the one with the less assumptions if they're equally explainable, right? If they have the same amount of explanatory power. Your model has no explanatory power. Let me explain to you what the cosmic microwave background radiation is, so you know for future reference. During the recombination period, 200, 300,000 years after the initial rapid inflation, there was a period of time where there was a sea of photons because there was no interactions between the electrons and the protons. So you didn't have atomic formation. You didn't have any helium and hydrogen being produced. So these photons were all kind of just going around in this opaque universe. As soon as it cooled down enough where atoms could form, instantaneously almost, all those photons that were circling around flashed out in a flash of light. They've been cooling off ever since. And the temperature that we expect them to be now, based upon the model showing what happened then, would have been 2.725, give or take. So when they found these photons, that exact same temperature level, they said, oh shit, this is spot on correct. There's no way we could have guessed this. The model is confirmed. And that's one of many things. I'm asking you, if that model is not correct, how did they were able to get such a specific number of 2.725 and be correct? That's all I'm asking.
Okay, let me answer it real simple for you. If it was an infinite shrink in this model, would you know the difference?
You don't get to ask me a question with a question.
Would it show up with the same number?
Yes. You do not get to ask me a question with a question. I don't like when flat earthers and dishonest people do that. I asked a very specific question. How did we get to that number if the model is not correct? Was this complete, utter dumb luck?
Well, I'll have to look into it more. There you go. Smartest thing. I think they got close to it, and they were and then they adjusted once they found the answer. But
no, it was actually well within tolerance. It was 2.7 of 3 they were looking at.
They weren't dead smack in the middle of it.
They were well within the plus or minus tolerance, I assure you.
Yeah, I know.
So I have a question. I have a
long time.
If you guys have resolved that, I have a question.
Yep, go ahead.
So as I understand it, in your model, we're on the inside of a sphere, surrounded by an infinite expanse of rock below us, and in front of us is an infinite expanse of galaxies and stars. And
the second half you have right.
Right. Well, and so as I understand it, also you say that there's a gradient that it isn't linear, but distances increase along a gradient as we go closer to the center of the ball, right? And become infinitely large or infinitely small.
There's more space and more mass.
Yeah.
Closer to the center you would get. And as far as the outside of the crust of the Earth, it still gets less and less.
Well, going from the surface of the Earth, what I perceive as the surface, going towards the center of the sphere, it gets infinitely able to hold more and more stuff, even though it's infinitely small.
Right. And it's the opposite. If you drill into the Earth, it holds less and less stuff until you get down to one atom that would be wrapping the whole Earth.
Okay. Right. So, but just going from the surface of the Earth to the center, where there's an infinite amount of galaxies and clusters of galaxies and superclusters, why? Why does it do that?
Well, I guess the way to put it is that the way it's the theology you were talking about. I look at it as what the purpose of us, right? Like I'm looking at it as there's a nothing outside of the earth in this model, absolutely nothing. And you have infinite on the inside. And can you have infinite and nothingness exist in the same universe, whatever you want to call it? Can there be?
Not really understanding your answer. I'm just asking from the surface of the Earth to the center or apparent center of this sphere.
Yep.
As the more I move, it becomes, the gradient increases, I guess, exponentially, and it holds more and more and more stuff within a smaller metric.
Yes.
And I'm asking, why does this gradient even exist? Why is this happening?
The gradient is needed because
there's meaning.
Well, it's not a matter of meaning. It's a matter of we know if we're going to say we exist, we actually do exist. The is. That which is, that which is not, right? That's all I'm getting.
So the reason that space is compressed like this is because the is, and we is, and we is not.
No, I'm trying to get to the point of it. I'm getting that.
I'm trying to understand, and you're just bullshitting me.
Okay, infinite. Can you have infinite and absolute nothingness at the same time without a gradient, I guess is the way to put it.
I don't know.
Can you go from nothing to infinite without the 1 through all the other numbers to infinite, which would continue to go forever? Can you do it without the gradient?
I think you can go from 0 to infinity, sure.
Right. And you can count, say, 0 from infinite.
Well, it could be linear. It doesn't have to, so if I have a number line, and I have numbers along that, I can go from 0 and I can count 1, 2, 3, 4 up to infinity, and every unit on that, that would be a standard linear scalar metric. It would just be 1, 2, 3, 4, 5. But you're not saying that. You're saying that I go 1, and then the next step that I take is much larger than the previous one, and then they just get they get smaller and smaller, but it holds spatially, it holds more and more and more. And I'm asking for you to explain why that is happening. Physically, why is that happening?
I'm saying the same reason it happens on your number line. You can't go from 0 to infinity. You have everything in between. There's a gradient. It continues to be a growing gradient or a shrinking gradient.
Growing and shrinking.
How you're going.
I don't know what you mean.
Even if you go square, you go 2 times 2, 4, 4 times 4, 16, whatever. You square it up. It doesn't matter.
I'm not understanding physically why this is happening. Why is it that as I get closer to the center, spatially, the space can hold much more and more within a smaller.
No. It's not space. Okay.
Well, that's what
as
you're
you
saying.
go closer to the center, there is more space and more mass. It's not.
But it's smaller and smaller, right? There's smaller steps. Each step is smaller, but even though it's a smaller step, it holds more stuff. That's your model, right?
Imagine it like this. If you put your hand above your head right now, you rose your hand up 2 feet above your head, 3 feet above your head, and you look at your hand. Your hand could have actually shrunk ridiculously. It could be 1/1,000,000th the size of what you think it is. But the light that's bouncing off your hand is coming back to your eye level, right where your eye level is. And it grows back to the exact same point of your eye level.
Okay. So why is that?
If I may, I'll just go away. All he's doing, and Brenda, imagine this, okay? Imagine having an eyepiece, and you're looking through, closing one eye, and you're opening the other eye, and looking through this eyepiece, and this eyepiece is a lens distortion. And all it does is it's convex.
Okay. Yeah, I can understand. I can understand the mathematical conversion he's doing.
Yeah, it's just doing a transformation. So he's looking at it through this little lens that's changing the light because it's entering from a different angle. and so it acts as like a convex lens, right? That's it. That's the only thing that's his model. That's it. Okay,
But
and you want to say that's reality? Okay, whatever. If that would do it, that isn't reality. That's just a transformation, but it doesn't do us any good. It doesn't change anything. It doesn't affect satellites. It doesn't affect going to the moon. We don't use any other different model.
Well,
No,
I'm asking
that
him to
Makes
give
it
me
more complicated.
I'm asking him to give me a physical explanation for why that is happening.
because there's no other way other than a gradient in order to make it where you can have a total of all things, an infinite in and of itself with
Well, sure,
nothingness.
we can just
And
do
if
it
you
the other
don't
way
have
around.
a nothingness, do you truly have infinite?
Who says there's nothing? I've
What
never
is this
seen
talking
nothing.
about?
Do we?
Oh,
Wait, have science demonstrated nothing can even possible? Because if it did, I missed that particular memo. When has science ever demonstrated nothing is even possible, or where
If,
exists?
that, if nothing, if there's something not possible, then there's not. Then there's a point of which there is.
Do you have
The
evidence that
infinite
nothing
does
that you
not
can
work.
actually have nothing?
It's a matter of, do you believe flat out that anything can be done? That there are infinite possibilities.
No. But so I'm asking you, according to laws of physics, can we ever have nothing? Just does nothing even possible? Because if there is, I know a lot of interested physicists to be willing to pay very much to have evidence for that.
The only way to have evidence of it would be to get outside of that which is something.
Okay, so I'm asking you.
In the gradient, that will never happen
All right,
for
so
us.
you have no
It is
evidence.
not possible. No,
All right,
it
so-
is not possible.
All right, so you have no
There is
evidence.
no point in any imagination where anything that has existence could prove nothing, because the
All right,
fact of
so
existence cannot show nothingness.
that's fine. So you are admitting that we have no idea if nothing is possible or not.
Yeah, we don't know or not, right? It could
Okay.
be either way. Sure. Could be either
All
way.
right. All right.
I choose to say, yep, it does.
I did a bunch of Googling. I can't find any explanation for the cosmic background radiation in an inverse model.
I wouldn't even know how that would work. I don't know.
I have
don't
no
even know what
clue.
you're-
I don't even, I'm not even finding an attempt at an explanation of it, actually. So,
Yeah, again, nothing. Again, if you look through a lens that's distorting stuff, and you want to say that's actually reality, hey, knock yourself out. But when you're actually making things work, if you want to use all that extra mathematics and extra transformations that is just going to balance out anyways and go back to the way it was normally, then go for it. But you're just creating an awful lot of work for yourself, and you're going to get the same result.
Less work. My point
no,
is
it's not. No, it's not. So
have you
had
ever done a
three.
matrix equation, Ireland? Have you ever done a linear transformation? They're
No.
paying the ass to do row and column transformations.
Oh yeah,
Nope.
that's why you program your calculator. Hey,
But
Peter,
no matter how you do that mathematically, which we already showed, where
You're
you're
not a
putting that
purist, are
aside,
you?
guess what? You actually have to show it. You have to see it. It has to exist. We have to.
but so
There has to
you
be
picked out those three
observations.
reasons. You picked out those three reasons that you thought your model made sense.
Right.
And two of those reasons made no sense, and I think the third one was kind of dumb. And so those are pretty small reasons, and then you're creating 100 other reasons your model doesn't work. So, like, to me, like, I'm gonna go with the model that works for
Well,
now. Yeah,
I don't think it works. I'm not going to say it works because it doesn't.
but it does.
It does. That's
No.
you could say
You
that all
do
you
not
want.
have
but
any
it does.
proof of dark matter or dark energy, which is
But
supposed to
how-
be 87 to 98% of the universe.
We
in
do
order
have
to
evidence
make what
for
we
it.
witness happen. Just because we witness it happen doesn't mean that that is what's doing it. You
We
guys
don't-
have
but
to
you're
make
not
that up,
giving
which
us-
there's no proof of.
You're
in
not
order to
giving
make
us
your model
any
work.
reason to doubt what we know.
Exactly.
It's
You're
not
pointing
known.
out
That's
a
the
few
thing.
things that we might not understand fully, but they fit our model anyway.
Yeah,
Right.
they fit your
There's
model.
no
That's
problem
why
with
you
them.
believe it. But
If they fit the model, then the model's not
Because
wrong.
they fit the model.
Well,
That's the whole
it
point, Ireland. They fit the model.
No,
Do
you can't. That's like the Bible when it says, "Guess what?"
No.
This
This
book
is
says
science.
it's true, right?
Lambda,
The Bible says
excuse
the
me,
Bible's
Ireland.
true, so therefore the Bible's true.
Do you know what
That's
the
all we're
lambda?
doing.
No, it's
circular
not.
logic.
Lambda.
Yeah, it
do you know
is.
what the Ireland? Do you know what the lambda cold dark matter model is?
Yeah, a new one that people are saying we got something new that we're not gonna. We have a new theory because that other one's.
Okay, so you have no idea what the hell it is. Granted. Okay, so
No,
you don't
I've
know
had
what
to
that.
bring up shit about, but I have not.
Well, yeah. Clearly, you don't know anything about this stuff. You don't know what transformations are. You don't know what matrix is. You don't know what linear equations are. You think you refuted something that you've no idea what the hell it even says. How do you refute a model if you don't even know what the model's about? You no idea what the hell you're talking about. What dark matter is a placeholder. We know that. We know
A placeholder. Yeah, an X factor, which is what I call.
No, it's not a fucking X factor. It is a placeholder for what we're saying. We are seeing. We are seeing. We are seeing. We are seeing. We are seeing distortions, and we know that matter causes gravitational distortions. We know there's something there. We know there's some matter there. We don't know what kind of matter. It could be baryonic, it could be non-baryonic, but we know there's gravitational force associated with that mass. We could map it. We could actually show we could actually show the concentration with a gradient of dark matter. There is something physically there.
Yep.
So we know something's there. We're calling it dark matter. Why do we call it? Wait, why do we call it dark matter?
Let's put it like this: if it's in every universe that we witness,
other
galaxy, not ours. Is it in our galaxy?
Why do they? Yes, it's in our galaxy. Why do they call
it right around the Earth? Should it be right here, right by us?
It's
guys, I'm about to go off here. So
no, you ain't. No, you ain't. I want Ireland to answer what the hell's dark matter, what he thinks it is, because he's the one saying that it's all wrong.
It's a magical unicorn fart that has no proof.
This is the expertise of flat earthers right here.
It has no proof.
Flat earthers and geocentrists, this is the level of expertise they're at.
All that dark matter is the placeholder, like you said, because the model,
the proof is the
computer simulation of what should be happening didn't match what we actually saw. So we put in a placeholder.
But it does match
what we have no proof of.
We can see the dark. We can see the effects of that
because we need it to work on our model, which we're using that to make our model work. But
no,
our model working is what proves that.
That's like say general relativity predicts black holes. Oh, we can't see black holes, but we can see the effects of black holes. We can work out mathematics and say, okay, there's something here that has this amount of mass in this amount of region, so it has to be this dense, ergo a black hole by all definitions of what a black hole is. But according to Ireland, it's not a black hole. That's exactly what he's doing. He's literally saying the same thing. Oh, and all the things we would expect for something that has mass to have a gradient in space-time, producing a lensing effect. But okay, but it's not mass. Well, then the black hole doesn't exist either, because a black hole is mass. If we can see the effects of things.
Have you proven it?
We don't prove anything in science.
No shit. I think that's kind of the whole problem here.
No, it's not. That's the strength of science.
And everybody says, man, all those flat earthers, all these other guys got to prove it.
No, I have never asked a flat earther to prove a goddamn thing. First of all, I don't think they can't even do simple math. So I've never asked them to do mathematical proofs either. But
you can disprove theories.
Yes,
but you can't prove them. So if I have a model, and there's some logical fault with it, or the evidence that directly contravenes it, then people talk, casually that they have disproved that model.
I have a question though for you, Ireland. Why do you care? Like, why would you even adopt this crazy model? What is the
things that the motivation? Flat earthers point out, that they go, look at this. This is fucked up with the globe. Look at this. Look at this. And a lot of them are bullshit. So don't think I just go, oh yeah, all their stuff's so great. But when they start seeing things like, why aren't we finding this? Why isn't this working? I go, because it's basically you realizing you're not on a globe and it's not working the way quite how you would think, but it doesn't prove flat either.
Wait,
Ireland,
so
can I answer it?
None of these issues are a problem on the inverse.
Here's the reason why
flat earthers argue about. There's no issue on an inverse at all. Not a fucking one.
Except for the cosmic background radiation.
Well, a lot of other reasons too. But here's the reasons why they do it, Shar. None of these guys are smart enough to actually take these courses and learn the stuff properly. So what they want to do is they want to feel special. They want to feel like they're on par with everybody else. And they create this asininely stupid thing that everybody else has ever had a basic education will look at and go, God damn, this is wrong. They're not smart enough to figure that out. And so they try to promote this. They try to promote this stuff as if it's fact. And yet, if you notice, every time, I love using every time I ask a flat earther, a geocentrist, or young earth creationist, or any of these guys, have you not noticed that none of them could give straight answers? None of them could give a model that actually makes sense. None of them could show the parsimony of it. None of them could show the mathematics. None of them could show the basic physics. None of them know what a freaking tensor equation is or a matrix equation. I mean, come on. They have no knowledge of the stuff, and and they are thinking they are smarter than everybody else, but coming up with some model
it's
that
like
nobody
any,
thought of before.
it's a
Okay, but
conspiracy theory. is what
it's-
it
No, no conspiracy.
Dunning-Kruger is what
is. It is a
I have no
conspiracy
conspiracy.
theory.
Absolutely, it's a
Yes,
but
conspiracy.
it
mine's not.
is.
Mine's
Yes,
not.
it is. It's
Why?
got the
I don't
same
think they're
motivations
hiding it on
behind it. I
purpose.
was just wondering what you thought your
Yes.
motivation was, because like
Because
it's
I
not
think-
truth,
okay, I think-
obviously.
I think mainstream scientists, all these guys who have gone through all the stuff he just said, make big fucking assumptions, and they keep saying, "Oh, we're gonna
There
find
it
the
is.
theory
Yeah,
of everything."
okay.
All these
Conspiracy.
things. Well, he
Yeah.
just he just assumed right in front of him. He
Conspiracy.
just said,
Yeah,
all these
no, it
people
totally
live
makes
there.
sense though. Yeah, you just
Not a
want to be
conspiracy
right about
because they have
something.
to conspire together to make a
And
conspiracy. Not what I
Strud, did you
said.
notice at the
Yeah.
beginning?
So
I've done this
obviously
dance.
don't know the definition of the word conspiracy. I
And I
Sorry.
think,
talked
yeah,
about it.
lack of education
sorry.
is just like, yeah.
Oh yeah, I've done this dance before, and do you remember at the very beginning of this, I specifically wanted to get his position on this because like I said, I've done this dance, and I tried to make him very clear. Do you think dark matter is the medium for light propagation? Do you remember me asking that over and over again?
Yeah, yeah.
Okay. The
It
whole
probably
reason for
is.
that, okay, now he goes like 2 hours later. He says, okay, you know why they want that?
It's a matter of
Because
because like
wait,
I don't know.
because
I'm willing to admit I don't know, which is a lot more
if-
than anybody
if-
who believes in heliocentrism would do.
if light has a medium, then obviously the results of Michelson-Morley are questionable at best. Would you right?
Oh,
and
yeah.
so
So
if it's,
if light has a medium, then Michelson-Morley shows that the Earth is not traveling through space, which would mean the fucking
no, I would say
heliocentric
it's
model is
inclusive. But
dead.
I would say it's inclusive. But listen, because we
Okay,
don't know
fine.
we don't know the
It's
type of material.
bullshit.
There's different
It
types.
says there's either no ether or there's
No.
nothing going through space.
Ireland, you do not understand. There's different ether theories. Lorentz had an ether theory. There's a couple different versions of ether theory. So you cannot say one size fits all. Okay, so it depends on the type of medium we're talking about, whether we call have an interference pattern or not. So don't just throw this out there like you know what the fuck
Fine.
you're talking
Okay, let's just say I agree with all that.
Okay, so it's the
Know
worst
that
case.
there's no
Worst
heliocentrism.
case, it makes the Michelson-Morley inconclusive, right?
No.
That means that people think, oh well, I might have a better model than special relativity. Okay, great. Let's say that even falsified Michelson-Morley, right? And it's not going to demonstrate there's an ether, but let's say hypothetically that it did. Special relativity still
it's not going to show.
Special relativity would not be falsified if we found an ether. It would still work. We would still use the model because it works. There you go. So it does nothing for you to promote this bullshit except tell and demonstrate to people that you don't want to be intellectually honest and you don't want to learn this stuff properly. That's the only thing it shows. That's it. That's the only thing you're getting out of this. And I don't know why you do it. You don't seem like
there's a proper way versus why not try everything possible. And see
you
what
have to
works
learn
best.
about something before you can have enough understanding to try to falsify it. You don't, and this is something you need to be self-aware of. Why don't you take the courses, and then once you learn about this stuff, and then maybe you might have a shot at this.
You know, I'm going through it as quickly as I can, considering I started doing this like 9 months ago.
And what courses are you taking right now?
Input on that, but
what courses are you taking right now?
I'm about taking courses.
There you go.
I don't have to go. No, not there. I go. I can get
Start
the
with
same books
college.
at home.
Yeah, you
I can
should.
read the same books. I can be self-taught.
Yeah,
No.
but there are college courses online that are free, and you should.
Yes, there are.
Okay.
I've looked at a lot of
If I were you, I'd start at college algebra.
But it was fun the first time.
And then trig.
Yeah, I mean, Ireland. I don't. Like I said, I don't. You're not getting anywhere with anybody. No, you're never going to convince
I'm
anybody.
not trying to get anywhere with you.
You're not going to get anywhere with anybody with
You're
an education.
indoctrinated like crazy. You have an
You're
exact
indoctrinated,
belief
Steve.
system.
Yeah, I
You
know.
You're
what?
indoctrinated.
Knowing these
No.
arguments is indoctrination, right? Knowing these
No.
arguments and knowing how to falsify them and debunk them and what the defeaters are clearly are indoctrination. Because
There's no defeating happening. I'm in here on a 5-on-1, which I really wasn't expecting when I got here, and I love it when Steve jumps in and runs the
401. I
show.
haven't seen anything yet. But what I do have to say is, don't let this distract you from the fact that if you or your loved one have mesothelioma or whatever it is, mesothelioma. There you go. You may be entitled to financial compensation.
Woo! Good to know.
What is mesothelioma?
isn't that asbestos for the lungs?
Yeah, he's talking about those commercials that show up on TV.
Oh yeah.
He's being funny, I guess.
Hey, Stuart.
What's up?
Anybody know Stuart?
Yeah, I do. I invited him.
Yeah.
You always said I can invite people I know.
Yeah. I'm going off air though. I'm going to sleep, guys. So you guys can talk about this off air. But
Yeah.
I gotta go sleep.
Before you